Hello, I'm Marieke Vermeulen and in this video I will explain how to do a scar analysis with MEDIS. So for the scar analysis we're going to do an analysis on late enhancement, but I can also do an edema analysis on T2 weighted to calculate the myocardial salvage. So to start off I have loaded a patient, which you can see over here, into the viewport, and I'm going to launch the uh, short axis scar, the normal short axis, but I will also load the T2 weighted image. Right mouse click, and this can also all be loaded in QMAS. So the three different series are loaded. By default it will show you the function short axis, and also here we can see that the contours are automatically brought in because this AutoQ file was present. So let us have a look. This is the SCAR, the late enhancement image. Please make sure to select the appropriate analysis type, which in this case is the late signal intensity. Initially, what we want to do is we want to get the contours in. So what you can do is you can use the trans button. What does the trans button do? It transfers the AI contours, the AutoQ contours, from the cine image on top of the late enhancement image. What you will see in this image is that there is a shift from the patient when we look at the cine image to the scar image. So what you can do is for all the images, you can press Ctrl Shift and you can shift the image into the appropriate location, and that you will repeat for all the slices. I have already done that over here. So if we have a look here, we can see that here I have already got the contours in for all of them. Also, we can see that here the scar is already highlighted. Just to show you where you can do that in the DSI analysis tab. In the DSI analysis tab, there are different methods implemented, so an automatic infarct size method, but also standard deviation and full width half maximum. For example, if I would like to apply the full standard deviation method, I can click on standard deviation. Auto copy means that you want to apply it for all the slices, and then you can click on this button to detect the hyper enhanced tissue like this. You could also do it more manually by using this slider and shifting it left or right to get a scar quantification. Also, a reference point is placed with this button. You can place a reference point here with the inflection point of the RV and the LV. This will divide the myocardium into different segments, so it will also allow you to call up a bullseye plot using this button. So here we see a bullseye plot and we can see the infarct size tissue of all the different segments. Next to bullseye plot, there's also here an overall table. So here it will show the infarct size in milliliters, grams, and percentages. The software will automatically detect hyperenhanced region, but in this case we have a microvascular obstruction, so we also have some hypoenhanced regions. To add hypoenhanced regions, you can use this, edit hypoenhanced regions. This will activate a smart brush, and this smart brush will never change the hyperenhanced tissue. So it's very easy and fast to also color the hypoenhanced region. So now we can see that we have hyperenhanced and hypoenhanced. Also this, when we go back to the bullseye plot, you can also have a look at the transmurality of the scar, and you can add everything to your report as well. In the beginning of this video, I mentioned that we can also analyze T2 weighted images. So if we go back and we select series number 1, this is my T2 weighted images, and the workflow is the exact same. So you transfer or you put the contours in, you select the method you want to use, and with that you can detect the edema. This is also shown here in the table below. If you want to combine those results, so you want to combine the scar quantification with the edema detection, you can click on this wizard head on the small button next to it, and you click on Combine T2 weighted and DSI analysis. It will give you again a summary of the T2 weighted and of the DSI analysis, and finally also the difference between the T2 weighted and the infarct size, which is also referred to as the myocardial salvage. When looking at the report, we will also see that again, the DSI, the T2 weighted, and the combination of the results are reported in the report as well.